Today's webinar, Real-Time Insights with GVERSE Geophysics. Today we'll be talking about the new enhancements and features in GVERSE Geophysics in the 2024 release, Triton. The agenda for today is as follows. First, we're going to talk about the new full and seamless integration of the on-the-fly seismic attribute computation and visualization capability of GVERSE attributes, including the new multi-view panel display, custom attribute creation using mathematical blending, and the ability to use all of your interpretation data during attribute analysis. Then we're going to go into the new inversion capabilities of GVERSE Geophysics, where we can calculate relative and absolute acoustic impedance volumes. Now into GVERSE Geophysics for the demonstration.
Here in GVERSE Geophysics, the first thing to notice is the new Attributes and Inversion ribbon, where I can call on new multi-view windows. Here in my multi-view dialog, I can choose which survey inversion I want to use, and I can subset my seismic into inline, crossline, and time ranges. Now, opening a new multi-view window gives me access to my multi-view ribbon. For those of you familiar with GVERSE attributes, you may recognize the majority of these tools in the new ribbons. Here in my Navigations tab is where I can step through my seismic data. And you can see that navigation is locked between my panels. And I can also choose whether I want to display inline, crossline, time slice, or horizon slice from the navigation panel. I'm going to start with inline, and I'm at the first inline of my set, inline 100. Here in the scene tree is where I can choose from different available attributes from GVERSE attributes. The first one I'm going to start with is average energy. Now you see that was calculated on the fly and my results were shown in real time. This is not an external volume that I had to import into my interpretation. Now the first thing I notice is this anomaly right here, and this is how the bright spot shows up under average energy. Now that can be cleared up a little bit, and that's the advantage of having this calculated on the fly. I can adjust my parameters until I get it right, taking it through as many iterations as I deem necessary. Now average energy is the square of the amplitude divided by the window size, and with any windowed attribute, the problem is coming up with that window length. The advantage of not having a volume that you generated it in and loaded into your interpretation is going to be incredibly powerful, since you would need multiple volumes with different window lengths in order to compare. Instead, I can tweak my parameters here until I get my desired attribute. And my changes are visible in real time. Now, average energy is a very simple attribute with not a lot of computes required. But other attributes like semblance, coherence, other geometric and curvature attributes, and even spectral decomposition require heavy computations, and we can do it all on the fly. To show you this, I'm going to switch over to time slice 1712. So we can analyze this faulted region right here. Now you can see here average energy isn't really doing a great job at showing me that area. So I'm going to switch over to one of our similarity attributes, semblance. And you notice how quickly that was calculated on the fly, and my results are shown here. Now I can clean this up a little bit by computing my frequency range. And the benefit of having this calculated on the fly is if I don't like what the software calculated that frequency range for, I can tweak my results until I get to what I like, all done on the fly. Now I'm going to go ahead and add 2 more panels so we can analyze 4 attributes in this area. So in panel number 3, I'm going to add another similarity attribute, enhanced semblance. And I'm going to go ahead and clean that up again. In the 4th panel, I'm going to add minimum curvature. And lastly, in panel 1, I'm going to add coherence. Now I'm going to zoom into the faulted area so we can see it in all 4 panels. We also have a few blending techniques to add deeper insights into your analysis. Co-blending can be accessed here in the blending tab and blends within the entire panel. But I'm going to take this a step forward and blend using our attribute overlay. So once I draw that rectangle, I can come here and I'm going to blend using a complex calculation from spectral decomposition. Let's go with dominant frequency. Now I can co-blend between those two attributes and see my results in real time. Now I'm able to see the structural information coming from my semblance along with the frequency information coming from my spectral decomposition. We also offer RGBA blending from the blending tab. But if we come back over into the scene tree, available attributes, one of our new attributes is what I like to call one of our new blending capabilities, is what I like to call mathematical blending, allowing you to create your own attributes using the expression calculator to combine existing attributes. You can add them, multiply them, run any mathematical operation on them, and blend them automatically. Now back into the comparison of these four attributes. Between the four, if you're looking for faults, enhanced semblance is really the best at giving you this information, compared to the smearing you can see here in coherence. Now if I were to navigate in the same time slice up here to this other channel-like feature, you can see enhanced semblance, which was so good for faulting, is essentially decimating the channel. I can't even tell the difference between that and the other features in this time slice. But let's look at coherence up here. And firstly, I can come and clean this up a little bit. I'm going to drop down my spatial smoothing and my time smoothing. And again, you can see my results are shown in real time, and I can see that coherence is showing my channel features really well. And that's the true power of on-the-fly attributes. You can figure out which attribute works the best for any situation without having to go through multiple volumes you had to generate. Once you've decided on which volumes you like the best for those situations, you can export them here. So I can come back through and go back through the different attributes that I liked in this analysis. So that was average energy for my sweet spots. That was enhanced semblance for my faulting. And lastly was coherence for my channel analysis. Now I can click Add to Interpretation and generate those volumes, and they are now available inside my interpretation for me to continue my workflow. Now the great benefit to having attributes now integrated into GVERSE Geophysics is that you now have access to your entire interpretation. Everything you have in your interpretation can now be added to your attribute multi-view panels. So I'm going to come and add my horizons by coming here, Add Horizons. Now in order to view my horizons a little bit better, I can quickly and easily come change the color palette of my seismic to grayscale. Now once I've made that switch, the first thing that pops out to me is this salt dome-like feature down here. Now in order to see the salt dome better, I can change my attributes, which are calculated on the fly, so I can quickly try different attributes to compare and see that salt dome more clearly. So over here in panel 2, the first one I'm going to try is going to be my frequency tune. Let's try dip steered semblance. Excuse me. Now I can see how that pops up, but I don't really like how that is. It's not very good. Let's see if we can do better. So I'm going to try a more complex algorithm from structural highlighting. Structural oriented filter. Much better. Now if I need the structure information coming from my horizons, I can navigate and see what my horizons are doing with any attribute in the background. And I can compare them in my multi-panel views. I can also add wells and view my wells and my seismic at the same time. Even my formation tops can be added here in my attribute views. With this seamless integration, any well data, if you have a time depth table, synthetic velocity models, they can all be used and overlaid during your attribute analysis. Now in the 2024.1 release, we're also bringing out Inversion, allowing you to calculate absolute and relative impedance volumes. The way we do that is to first design an inversion operator here. Now what that does is takes your seismic right here from any volume you have in your interpretation, and you can even subset in time, inline, and crossline range for processing abilities. And clicking Load Traces calculates your amplitude spectrum. I'll go ahead and expand this so we can view that a little bit better. which can also be smoothed to remove any jumpiness represented by this blue line here. Next, you select your wells. Once I load my wells can be my desired wells can be selected, and sonic and density is taken to calculate my impedance logs. Now my impedance logs are then taken and we do a seismic spectrum for that, creating this green line here, which is then subtracted from the seismic, resulting in this black operator line. Now over here in my parameters, I have the ability to adjust my well fit parameters in order to get a better slope and intercept to fit my wells. I also have the ability to change my Butterworth parameters. I can see my high cut here at 80 is a little high, so I'm going to go ahead and drop that down to 60, and I can see that that results in a much more realistic inversion operator. Once I'm happy with my operator, I can go ahead and save that operator 1. Clicking save, this is saved at the project level. So there's no need to recreate this across interpretations. Anybody who wants to use it can. Now I can come here to my second panel, and now that I have my inversion operator saved, it is here under my color inversion, and I can apply it on the fly as an attribute. Now this is giving me my relative acoustic impedance. If I want to turn that into an absolute acoustic impedance, I need to create a low frequency model here. In my low frequency model dialog, I can combine my horizon and well data in order to create my low frequency model. And that model is then incorporated into my inversion to get an absolute inversion model. Now this is just like attributes. This low frequency model can be applied in real time to give me my absolute colored inversion, and I have my multi-view panels to compare. I can even display my low frequency model as an attribute here in my other panel and continue my comparison. Now once you're happy with your inversion, you can export that volume just like you did with your attribute volumes. By coming here and select colored inversion, and I can export my operator 1. Selecting add to interpretation and generating is again going to add that directly into my interpretation for me to be able to continue my workflow. Now this was just a little bit to show you the power and efficiency of the on-the-fly attribute computation capabilities now seamlessly integrated into GVERSE Geophysics.
I just wanted to say thank you to everyone for attending today's webinar. If you have any questions, I'm available to receive them.